Okay, I'll tell you that NH3 and HCl, this information is provided, reacts with the HCl particles and they produce this thing called ammonium chloride. You don't need to know this right now, okay? So they produce this thing called ammonium chloride and it's a white solid. So the question is, okay, so the two gases are going to react somewhere in the middle and they're going to produce this white solid. So this gas is traveling, diffusing, this gas is also diffusing. My only question is, where would they meet in the middle? Where would this white solid be formed? Would that be position A, right in the middle? Would it be position B, or would it be position C?
A, because it's right in the middle.
No, but okay, that makes sense. But do you think the two particles?
Actually, no. It will go at B, but it's the one on the left is a gas and the one on the right is a liquid.
No, both of them are gases. I mean, they evaporate. Both of them evaporate. I mean, both of them evaporate. This changes into a gas. Okay.
Okay. Oh, so it will be C, wouldn't it? Because it's smaller particles. Or no?
Which one? Penedo, decide which one has the smaller particles. Is it this one? You need to look at the pure table.
Oh yeah. Okay. So 14 add. So that's okay, and that is okay. So it will meet a B because NH3 is lighter and it has smaller particles.
Okay, it's lighter, so it has smaller particles. It's going to travel.
It's quicker than the other one.
Okay, so it's going to travel a lot faster. So it's going to meet at B. Okay, so that's fine. So this is the point. The two particles are going to meet, and the white solid would be produced somewhere over here in the middle.
Okay. Yeah.
What was the mass of NH3 that you got?
Of NH3, it was 17.
Okay, so it was 17, and the other one?
That is 36.5.
Okay, that is 36.5. So that's fine. Okay, so you might get questions like this, slightly more tricky ones. Then there's another one. Let's do another question. Okay, related to this. This other question is you have this beaker, this inverted beaker. This is an inverted beaker, and inside there's another beaker. Not a beaker. It's a porous pot. I'll explain what a porous pot is. And that porous pot is connected to a tube, and the tube has two ends. I'm just trying to draw a rough diagram. So this is kind of the diagram, right?
Yeah.
And this one is a porous pot. What it means, what is meant by a porous pot is that it has small holes in it, tiny openings in it, and the gases can kind of move in and they can move out through the walls of the container. Okay, is that clear?
Okay.
The blue one. You can focus on the blue one. This is not closed. I mean, this entire tube is connected, right? So this is a porous pot. Gases can move in, they can also move out.
Okay.
Now this beaker outside, this beaker on the outside, this beaker contains a gas, and it contains a methane gas, CH4, right?
Okay.
So the outside of this blue pot, let me shade the blue pot slightly. I won't be able to write it. Just get the point. The red container outside, it contains methane gas.
Okay.
And the container and the gas that's inside the blue porous pot is hydrogen gas.
Okay.
And the question is, that there is liquid that is present in this tube
Yeah.
over here. So there's
Mm,
liquid present over here, and you're
mm,
being asked what's going to happen to this liquid. Would the water level rise at this point, at point X, or would the
mm.
level at this point fall? Okay, that's the question. So I'll just explain this a bit more. Okay, just to give you some more clarity. So let's assume that these are all the hydrogen gas molecules inside the
Okay. Porous pot.
porous pot, and they're also inside this because it's connected. So they're also inside this place over
Yeah.
here, and
Mm,
they're basically pushing the liquid down. The particles are colliding and they're exerting pressure. Okay, remember the idea of
mm.
pressure?
Yeah.
So they're kind of pushing the liquid out.
Okay.
And there's methane gas on the other side. So let's say these particles over here, these are methane gas molecules, right?
Okay. Mm.
And so now can you guess how would diffusion happen? What would the green particles do? Where would they move?
Would they move downwards?
No, they're going to diffuse. I mean, this is remember
Yeah.
the walls
Never.
are porous. Walls are porous.
Yeah. Okay. Because so H2 is lighter than CH4, which means it would diffuse quicker.
But where would they diffuse? I mean, they move from a region of higher concentration, so the green particles are at a
Yeah.
high.
So, yeah. So they move into the red box basically.
Okay, so they're going to try and move outside, right?
Yeah.
So the green ones are going to try and move outside.
Yeah.
And what about the blue ones? Where would the blue ones move?
They're gonna try and go inside.
So the blue ones are going to try and travel inside.
Mm.
Who's going to diffuse faster?
H2
So that means
hydrogen.
okay. So that means right at the beginning,
Uh,
as soon
Yeah.
as you start this experiment,
Mm.
all the green ones, and there's a huge difference between H2. I mean, this is 16 and this is kind of 2. This is 2.
Two. Yeah. Yeah.
So the speed, there's a huge speed difference, right? So the green ones are very, very fast. And they're going to
Mm.
move out, they're going to try and move out very, very quickly, but they're very fast, right?
Yeah.
So
Yeah.
all the green ones are going to try and move out. So they
Mm.
quickly try and but right at the beginning, so what would happen to the amount of particles in this pot over here, the blue one?
It, it would obviously decrease.
It will obviously decrease. So there would be more and more particles quickly, very quickly trying to move out. So even these
Mm.
particles, they'll just kind of, I mean, this tube would become, I mean, a vacuum is going to be created, right?
Mm.
Because all the particles are getting pulled out. So
Yeah.
there would be lesser and lesser particles
But in the tube.
in the tube. Okay, all of them.
Yeah.
Let me kind of move them out. Okay, so these particles are kind of moving out. So if there are lesser particles over here, what would happen to the pressure in the tube?
The pressure would obviously decrease.
So there's no one pushing down the liquid, right? There's nothing.
Yeah.
So the liquid would start to rise.
Rise.
Okay, it's going to start to rise, and
Mm.
uh, and what would happen to the water level at X? It would start to
It would go down.
it will start to go down. Okay, so there's no one pushing the liquid down, so the liquid starts to rise on this side. So on this side, the liquid starts to fall.
Fall down.
Achha,
Yeah.
just another question on the right side.
Mm.
Why is it falling down? Who's pushing it down?
Gravity.
Okay, the gravity is one, but also the atmosphere. I mean, there's lots of air particles outside, right?
Yeah. And they're pushing on the edge of the container
Okay, I mean the
or
container.
the tube.
Let's say this is open, right? So the
Yeah.
particles, so the air
Oh.
particles. So so there are
Okay.
two
Yeah. Yeah.
there are two things that are pushing the liquid down. One is gravity,
And
and
where's the air?
and the other one is the atmosphere. I mean, nothing happened to the atmosphere, so it's still pushing it down.
Yeah. Yeah.
But there's no one pushing on the other side. which is
Yeah.
why the liquid would start to rise on this side.
Mm.
I said, now the other thing, would it remain like this? I mean, this just happened at the start. Would it remain like this, or would there be any difference now after some time?
No, after some time, then I go back to before because the CH4 would go into the tube as well partly, and it would
Okay,
equal out afterwards.
okay, it will equal out. So slowly, but eventually, these particles of CH4 they're going to diffuse in slowly. Okay,
Yeah.
but so they're going to take some time, but they're going to eventually diffuse in, and they're also going to go into the tube as well. So
Mm.
there'll be more particles in the tube now back again, and the particles would start pushing down, and the level would again come back to the same level, right? So initially, so
Yeah.
we're going to write an explanation for this. So initially, what happens is right at the beginning, uh, what happens is the green wale, which is H2 particles
Yeah.
diffuse out at a faster rate. I said H2 particles, initially H2 particles diffuse out. I forgot to write out. So they diffuse
Mm.
at a faster rate.
Okay.
And water level rises.
Mm.
As there is lesser pressure. Why? Because less gas inside the porous pot.
Mm.
I said, so less gas inside porous pot, and then the other explanation is, but eventually, so water level, I said, did I say water level? Again, water level rises as there is lesser pressure, less gas inside porous pot, but eventually, I said, but eventually, CH4 molecules are going to diffuse in.
Mm.
So eventually, CH4 molecules are going to diffuse. Let me make this bigger. CH4 molecules are going to diffuse inside the porous pot.
Mm.
And pressure increases again. And your water level.
Returns back to where it was.
Okay, so water level, how would you phrase it? Comes back to the same level. Right? Is this clear, Afif?
Yeah.
So now what we're going to try and do is we're going to try and attempt some questions now related to kinetic particle theory. We haven't done a few things, so we can do some questions, practice some questions first, and then we can
Yeah.
come back to this. Just 1 second, let
Yeah.
me disconnect and open the worksheet. I'm disconnecting the camera as well. Wait. So you can 1 second. Just give me 1 second. So now we're doing kinetic particle theory. You can see the screen, right?
Yeah.
Let me find the worksheet proper. This one. So kinetic particle theory. So this one. Let's start. You can see the screen, right?
Mm.
Let's start with the first question. Question number one. What do you
Mm.
think? What's the answer? He's saying there's a diagram, solid, liquid, gases. He's mentioned the changes in states. So tell me, which statement is the correct statement out of the four? A, B, C.
A.
Yep, that's the correct statement. Okay, that's obviously that. What's wrong with the B?
Please 1 3. So that one. So in change one, the particles are getting further apart.
Change one. Yeah, that's right. What about C? What's wrong with C?
I can just do together and then four. In four, they're getting closer together.
In four, they close. Yep, that's fine. What about D?
Okay, number three you have to gain more energy.
Number three needs
No,
to.
wait, no. It release energy. Sorry, never
Yes.
mind. Liquid. Uh, number so solid, solid to gas. You need to gain energy, which is number five. So number five needs to gain energy.
Okay, that's fine. So that's wrong. Let's move to the next one, which is something that we just did. Uh,
Mm.
so very quickly, there's ammonia gas, and he's saying they form this white deposit when they react.
Mm.
So there's ammonia over here, and there's HCl on the other side.
Okay.
What's going to happen? Where would they meet?
Once again, 15. 36. At, at D.
Okay, so D is correct.
Yeah.
So then, next question is somewhat similar, except okay, there is ethylamine gas. He's saying the same thing that they form a white solid when they react. But over here there is C2. So the formula is
Mm.
C2H5NH2. Okay, this is the gas
Okay.
that's being released, and over here there's HCl. So where would they meet in the middle? You can find the mass and then do the working.
Okay. So, 24 equals 45. And that is 45. You get tricky. It'll be a C.
It will be C. Why would it be C? Which
Because
what is
it's
what is
45 and 36 and a half.
this is 36.5, yes.
Yeah.
Is this just let me figure that out. It's 24,
It's,
two carbons, plus it's 5, so that's 29 plus 14. What's 29 plus 14? 43 plus 2, right? So
45.
this
Yeah.
is 45, that's fine. So why
Mm.
C?
So, it'll be B.
B I think is right
B.
at the center.
E. Wait, is B okay? Then it's A. Okay. I thought B was the big dash, so then it's A.
8, yeah, that's 8 because this is faster.
Yeah. Yeah.
So it's going to travel a larger distance, right?
Quicker. Yeah.
Now next one. You think when drops of bromine are placed on a tabletop at one side of a room, the smell of bromine can eventually be detected at the other side. What is not part of the explanation of this?
Uh.
Like bromine particles at one corner of the room, they spread out and you can smell it at the other end.
So It's not B or C. The collide with it's D.
Yeah,
They
because
don't. They yeah, because if it's a gas, because it
yeah,
comes a gas.
yeah.
So yeah, liquids vibrate from side to side.
No,
But
not
no, solids vibrate from side to
yeah.
side. Liquids and gases can slip and slide past each other. Liquids can slip and slide, and then gases can move freely.
Okay, that's fine. So basically, you have solids don't diffuse. Solids don't do that. They don't jump from one
Yeah,
corner of the room to the other corner of the room. So vibrate from side to side. That's incorrect. So you were supposed to mark the incorrect one.
yeah.
This one. What process provides the best evidence of the particle theory of matter?
Uh,
I mean,
I don't know.
I tell you, this is a simple question. It's just that you studied diffusion kinetic particle theory, right?
Yeah. Oh, okay. So you okay?
So that's it. Take it.
Yeah, yeah. Okay.
So this one, quickly tell me, you're saying the balloons, the gases gradually diffuse out of the balloons. So the gases are coming out of the balloons. Uh,
Yeah.
so which pair of balloons will deflate at the same rate?
So choose 28. So this is 28, and this one is 12. Uh, so 12 add 16, 28, 16, and then 28, 16, 28, 40, 17, 12, 24, and then 24, 40 to 28. So R and S,
R and S, because both of them have what mass?
the same atomic mass, 28, relative atomic mass.
Okay, so they have I say it's called molecular mass if it's a molecule.
Okay,
Okay, molecule is basically multiple atoms. So if it has more than one atom, you'll call it a molecule. Okay, molecular mass.
okay, okay,
One single atom, that's atomic mass. And the
okay.
next one. Next one is which statement explains why the gases there's propane and carbon dioxide. Why do they diffuse at the same rate?
Because uh, C3, uh, because they have the same relative, because they have the same relative molecular mass.
Okay, and what was that?
C3, so CO2, 32 add 12, 40, 44.
Okay, so it's 44.
Yeah.
Uh, okay, that's fine. Next one is that a drop of liquid bromine is placed in the bottom of a gas jar. Brown fumes of
Mm.
bromine. So he's already told you that bromine has brown fumes. They
Okay.
slowly spread through the covered gas jar. Why does this happen?
Because bromine molecules and molecules in air are always moving around.
Okay, that's why they're spreading out. Okay.
Mm.
Then you have this question. The diagram
Mm.
shows a diffusion experiment. Which gas, when present in the beaker over the porous pot, right? I
Mm.
mean, he's basically talking about this point.
Mm.
Uh, which gas present over the porous pot, and there is oxygen gas inside the porous pot, right?
Mm.
Will cause the water level at Y to rise. You want the water level at Y to rise.
Okay. Uh, 82.
So how do you figure this out?
So 82 and C CH for methane because that has to be lighter, which means it'll diffuse in quicker than it, which will
Which
make
one?
more pressure go down. Be C.
C. Okay, that's fine. C is fine. Okay, because you want the gas to come in faster. This is 32.
Quicker. But
Yeah.
then, yeah, then that one that quicker than that one can escape. Then
Yeah.
there's more pressure which pushes it up.
Okay, so there would be more gas coming in at a much faster rate, and it would be pushing the liquid downwards. The next one is, and the next one, this one. Boiling points of various gases found in the air are shown. If the air is cooled, he's cooling air, right? So the first substance to condense is water. If the temperature is lowered further, so he's bringing down the temperature. What is the next substance to condense?
Carbon dioxide.
Carbon dioxide, yes, that's fine. This one, although we haven't really discussed this, but you can probably answer this. What correctly describes the molecules in a very dilute sugar solution? Do you know what dilute means?
Yeah, like so. There's a very small amount of sugar in it.
Yeah.
So mm, so why is it not moving down? Low, close together, moving around, close together, moving around. So B.
Which one? B. Widely separated, moving at random, close together, moving at random. Okay, that's fine. Dilute means okay, just we can also discuss it. 1 second. The liquid, there would be lots of liquid molecules, so they would be all close together.
Yeah, and then there'll be small amounts of sugar molecules, and
So,
they obviously have to be far away from each other.
okay, so they would be far apart from each other. The
Yeah.
next is the conical flask contains compound X, which is present in solid. So it's present somehow the solid, liquid, and gaseous state of X, they're all present together, right?
Okay.
I don't know how that happened, but it's present together. Uh,
Okay.
which statement is correct? A, B, C, D.
Energy is released when exchange from liquid to solid. So B.
Energy is released the liquid. So yes, okay, that's fine. Next one. Why does neon gas diffuse? This one is an easy one. Why is neon diffusing faster?
Because they have neon atoms have the lower mass.
Answer this one. Which is a gas out of these four?
A.
Which one do you think is a liquid?
C.
Okay, that's fine. The next one is which gas diffuse at the same rate as nitrogen? As I remember, although we haven't studied atoms and compounds, do you know what carbon dioxide is?
The CO2.
Carbon monoxide,
CO.
neon.
Any
I think it's a noble gas. It doesn't
SO,
really.
and
This
then it's
is.
SO2.
I said so. Which one is going to diffuse? Remember, nitrogen is always it's a diatomic molecule, so it's N2. We're going to discuss this. We're
Okay.
going to study this later, but so which one? What's the answer to this?
Um, C. Neon. Where's neon? Um, 24 SO2. So it will be 24. So 28. Yeah, okay, so it will be carbon monoxide, B. Because they're both equal 28.
Okay, so it's TK. That's fine. Next one is we talked about this. What property shows that a liquid is pure?
It boils at a fixed temperature at a given pressure. D.
Okay. As now, out of these gases, which elements would be? This one is a slightly tricky one. Which table? Which of these are gaseous at -190?
Okay, so uh, um, helium, helium, neon, and nitrogen. C.
Helium,
Neon
helium,
and nitrogen.
and nitrogen. I think that's fine. So if I say we can skip the balloon question. I said this one. Read the question carefully. He's saying that nitrogen dioxide is a dark brown gas. This one over here is dark brown. Plus, it's also more dense than air. What that means is it's heavier than
It's
air.
heavier. Yeah.
So he's removing the glass plate. There's a glass plate that's dividing the two things.
Mm.
So the glass plate is removed. Which one of the following correctly describes the colors after a long period of time?
Um, it's heavier, so then the bottom one has to be. Okay, A. Brown, because they'll be equal, because eventually they'll both diffuse. Actually,
Again,
no. 1 second. No, okay, D because some of it will be light brown, some of it will be dark brown. Because wait, yeah, because or will it be C because it's all of it's heavy, so it'll all go down. So it'll
no,
be C, right?
no, it won't be C because remember it's a gas. I mean, let's say these are nitrogen gas particles.
Yeah, well,
They're
it'll still diffuse, right?
they're heavier, right?
Yeah.
And let's say these are air particles. They're lighter, but it's not going to
Okay.
be a very clean separation because particles can still they can move in all directions, right?
Yeah. Okay.
So some of the
So
brown gas particles, even if they are heavier, they can still sort of move over here.
so even if you left it for a million years, it would still be some brown in the top
Because
though.
nee, because if it's a gas particles are randomly moving around in all directions.
Okay.
Okay, but so some of the gas particles can
So
also,
yeah, but in general, there'll be more there'll be more towards the bottom, but some will still remain at the top.
yeah. So it's going to be
Okay.
light brown and dark brown. That's what's going
Okay.
to happen.
Yeah.
As then next one. So this is easy as well. Is I think it's getting repeated. Uh, Now this question is actually the opposite of what we studied earlier. In this question, so you probably do you know what a litmus paper is? You must know what a litmus paper
Yeah.
is.
It tell you what the pH of something is.
Okay, do you know what the color changes of a litmus paper are?
Is it the same as universal indicator?
No, it's not. It's no universal indicator has a lot more colors. Okay, a litmus paper is like a more sort of a cheaper version of a universal paper. It only has two colors. In acid,
Okay. No.
in
Because
acid, hmm?
in,
In
'cause
acid,
in school in school we only use a universal indicator. That's why.
ठीक है, that's fine, but universal indicator has a lot more colors. ठीक है,
Yeah.
so
Yeah.
so
Yeah.
in
True.
you go do you go to a lab frequently?
Yeah. In school, yeah, we used to before it happened.
Okay,
Coronavirus happened. Yeah.
your schools are still not open.
No, not yet.
Okay, so I'll just tell
It's
you.
it's the hot. It's the holidays anyway. They're gonna open in September.
Okay, that's fine. I'll tell you the colors of a litmus paper. And in an acid it's red, and in an alkali it's blue, right?
Okay.
Now, this is an asset. ठीक है, I'm going to give that information. HCl is an asset. Hopefully, you already know that.
Yeah.
If
Yeah.
you
Yeah. I know that.
do you know what NH3 is? I mean, you must have seen it in the lab. Have you seen it? Have you actually seen this in the lab?
I don't know. I don't think so.
As it's
What's it called?
I mean, it's a very popular. I mean, students really like this because it has a very irritating smell. ठीक है, it's a very sharp, pungent smell. So
Oh.
so students they sort of I don't know why, but they like to smell it a lot. So
Oh.
so NH3 over here, okay,
Hmm?
it's an alkali, not red.
Blue.
It's an alkali.
Yeah.
So
Okay.
it's going to change it into blue. The HCl is going to change the litmus paper into red, right?
Okay.
So all of these gases, he's saying that this NH4Cl, when you heat it,
Hmm.
it
Hmm.
breaks down into these two gases. So these two gases are coming out.
Okay.
Which gas do you think reaches the litmus paper first?
Okay. So NH3 because it's lighter. It has a smaller molecular mass.
Okay, so it's going to be blue first,
Hmm. And then
because,
red.
and then after some time the HCl would reach and it would turn it red. So the answer is,
Hmm.
which one is the answer?
Blue then red. D.
Okay, so it's D. Now, next one. This one is kind of a tricky question as well. A test tube containing a liquid X is placed in a beaker of boiling water.
Hmm.
So there's a test tube
Hmm.
and there's boiling water, right?
Hmm.
And this has X in it. The test tube
Hmm.
has X in it.
Hmm.
So the liquid X starts to boil immediately. What is the boiling point of
Okay.
what is the boiling point of liquid X?
Um. Above 100 degree. It's either A or B, right?
No, you have to be sure about. I mean,
Okay. So it'll be
need to think about all four options.
between 0 degrees. Uh.
And the first thing.
Oh, okay. Yeah. LBD. LBD.
Okay, why would it be D?
Because it wasn't boiling in room temperature, but when you put it in there, it started boiling. So it means it has to be somewhere in between that, in between that
Okay,
process.
see, that's fine. So I mean, this is 100 degrees centigrade. So if it boils immediately, that means it must be lesser than 100, right? That
Yeah.
because if it had been more than 100, then it wouldn't have boiled. And the
Yeah.
other
And
thing
if it
is,
was 100, then if it was 100, it won't have boiled immediately, right?
but even then, I mean, it's um, probably it's going to take some time. But yeah, right. That's your idea is fine. I mean, it must be
Okay.
probably quite less than 100 to boil
Yeah.
immediately.
Yeah.
And the room temperature thing is also fine because it was a liquid. It wasn't boiling at room temperature,
Hmm.
so that's fine. I said this thing. I told you something about this. What happens if you add a salt to aqueous? Aqueous means water. If you add
Okay.
NaCl to water, what happens to its boiling point? At what temperature does it boil?
If you add any solid to any liquid, what? Uh.
I mean, there's water and he added salt to it. Water has a
Okay. Then
boiling point of 100, and now he's added salt.
they will go. It'll go higher.
Yes. So it's going to be
104.
see. So
But
it's going
why
to
does it go higher? What's the reason for? What is the reasoning behind this?
okay. Why does it go higher? The reason behind that is where's some. Let me get some white space. Wait. Asha. The reason it goes higher is that it kind of becomes more difficult for it to evaporate, right?
Hmm.
So I'm going to let me try to make this easier. I said these are the water molecules, right?
Yeah.
So they have attractive forces, right? And they
Hmm.
become energetic, and the
Hmm.
particle evaporates and escapes in the air.
Hmm.
This is what's
Hmm.
happening.
Yeah.
So now when you add a salt, it becomes more difficult. NaCl specifically. Reason it becomes most difficult is that NaCl is an ionic compound. It's Na plus one and Cl minus one.
Hmm.
They kind of, if you add NaCl to the mix to water,
Hmm.
what they do is they start attracting these particles to themselves. I don't know why.
Okay.
Okay. So it's kind of the particles. It becomes more difficult for the particles to escape.
Okay.
Is that clear?
Yeah.
And why does melting? So the other thing as well, melting becomes easier as well with NaCl. That pretty much has the same logic as well. Like in ice,
Yeah.
the particles are
Hmm.
attracted to each other. So let's think
Hmm.
of these particles; they are strongly attracted to
Yeah, and then when you add something, then something else pulls them away from each other. It
Yep.
makes them
So
more liquid
these
form.
these particles, they are getting pulled. So the bonds over here, they're going to get broken.
Okay.
So the structure side kind of becomes weaker, and it becomes easier to melt it.
Mm. Okay.
So that's the logic behind that. So ठीक है, we're going to continue tomorrow then with this, and we're going to
Okay.
do some more questions. What was the
Okay.
last? I just forgot. What was the last thing that you studied in school?
One second. Let me check. I can't quite remember because it's been so long.
No,
Let me just check my book.
you haven't had any online classes.
No, no, since quite a while because the holidays have started, haven't they?
Okay.
We did about potable water.
Okay.
Potable water. Yeah.
ठीक,
But that was just.
do, you, do, you,
But
do,
that
you,
was. Yes. Sorry.
do you have a book?
Yeah, I have a book.
If the book probably has the titles of the chapters written on one page,
No,
right?
no, no. The book is by me. I wrote in the book. The book is of my notes.
I said that's you have your notes, right?
Yeah,
You
basically.
you don't have an
But
official
no,
recommended
I
book.
don't have an official book. No.
I said, okay, send me. But the notes would be lengthy. You can't really
Yeah. There's a
scan them.
few. Yeah,
Can
there'll
you
be so many pages.
yeah? Can you do me a favor? Just write like just the topics. If you can sort of figure out 7, 8 topics that you studied by looking at the notes.
Okay.
Okay, that'll just give me an idea of where you stand.
Okay.
Okay. So just try and send that in somewhere in this week. Okay.
Okay.
So ठीक है, okay, Afif.
Okay. Good office.
Take care, Allah Hafiz.